or maybe we can wait for 1 or 2 minutes. We'll just wait for people to join, maybe 5 minutes, and we'll start from 4:05. We will discuss on Sir's week 5 lectures, classification functions in scikit-learn. And yeah, so we'll discuss the slides, we'll discuss the collabs, and we will discuss the practice questions. So some activity questions in this course, many of our friends have pointed out that there are some mistakes, at least 3-4 questions we found, three questions we found. So they asked for some corrections. We are doing those corrections. So in case you also find any correction, you can inform us in the chat window or by switching on your mic. Okay. So if we will go through them, and whatever be the corrections, we'll just inform. We'll update the corrections. What happened is, so previous time when we were doing, this is the second run of the course, and previous time, so sir was also recording. Everyone was in a deadline. Okay, so that's why I think many of the errors have crept in, and we were also pretty new to the course. So that may be the reason, but whatever be the reason, we have to correct the errors, right? We have to correct the mistakes. So yeah, I think Anand Ayar and other friends of ours in the course have pointed out, other students have pointed out some corrections. So we are doing some of those corrections. Let us know if you find any more issues, any more corrections. We'll try to figure them out. Okay, and yeah, so yeah, I mean about that. Also this week there is a quiz. There is quiz on week 1, 2, 3, 4, right? On MLP. So obviously best of luck on your quiz preparation and everything. So quiz 1 mock, we will obviously we have to publish. So quiz 1 mock we will publish, and we will take a revision session on quiz 1. We'll try to figure out when to take the revision session. Okay, so because the other normally the MLP class session happens in Saturday 11 to 1, but 11 to 1 you are going to give the exam on Sunday, and Saturday sitting for a revision session sounds, I mean, very at the last moment, right? So we would like to take it maybe one. We'll try to see where we can accommodate. Huh? Maybe on Friday sometime we will announce beforehand when we are going to arrange the revision session. We'll just do a quick revision of all 4 weeks, data loading, data pre-processing, and the remaining things, whatever is there, the regression parts. Basically, my opinion. Hello, yeah. Anyone wants to say something?
Yes, sir. I just want to say, like, the exam is basically going to be like all the question, like, questions from the documentation, right? Like of the scikit-learn.
Sorry, of the
The,
scikit-learn.
yeah, the skill-learn documentation. Like, if we go through that, that would kind of be
Yeah,
enough for the
more than
exam, right?
enough, more than enough. But that is a very daunting task. Still, I mean, if you can do that, you are a genius, sir. But I mean, taking the full scikit-learn, if you can remember. But we won't ask for all of those things. We will ask for small things in based on the examples. Okay. So if you know, like say one hot encoder. Okay. If you have studied the one hot encoder example which was taught, if you have also gone through the examples in maybe the manual, okay, the way scikit manual, okay, a scikit-learn manual, if you have gone through, that will be great. Actually, you can. So what we can ask is what is the output of the following code, and then we give you a code for one hot encoder, or say log 1p, or whatever, some function transformer, then maybe a pipeline. We'll give you the, say we will give you a pipeline description. Then we'll ask, and then we have written the code for calculating the length of the pipeline. Then we ask you what is the length of the pipeline, what is the answer. So based on the pipeline description, you can answer that. Also, there mostly what is the output of the following block of code. Okay, like that it will be there. Okay. Apart from that, if there is any formula in the in search videos, okay, that will be important. So if sir has taught like epoch, is there any formula on the epoch somewhere? In week 2, week 3, in pre-processing, sir has told something. Then confusion matrix, if some portion of confusion matrix is there, how to, I mean, what are the different parts of confusion matrix? What is the different parts of a classification report? What is precision recall? All small things like that. Some small definitions. Those will be important. Mostly, it is tried not to make it a very, I mean, remembering type of question, but it is like, I mean, based on your whatever sir taught, it will be based on the sir slides and the collabs and all. Okay, nothing out of syllabus, nothing like which is even if it is there in scikit-learn manual, but if sir has not described, won't be there. Okay, that is taken care of. Yeah, so that's that mostly. I mean, I don't think it will be too much difficult. So I expect a high scoring paper. Okay, I mean, I expect a high scoring quiz. Should not be very much difficult. It is like a little difficult. I mean, like, not, you will if you open the slides, it will not like, it will be very immediately you find the answer, nothing like that. But if you understand what the thing is doing, then it should not be a problem, I mean, it will be very easy. Should be I mean, you should be able to do it, I think. Just a normal paper, not very high level something, nothing like that is there.
Okay,
Let's
sir.
see, I mean, yeah, sure.
Sir, and a little one more question. When will we be briefed about the MLP project?
MLP project, yeah, actually MLP project, so um, in the previous session, which I think was happened on which happened on the this week, this previous week, I think on Friday or Monday, some session was held, right? Were you informed about the general guidelines, the basic guidelines which were there?
I'm not sure, sir. I was not there. Like the session was on Saturday, last Saturday.
Yeah. So basic guidelines are mentioned, I think. I mean, what is the MLP criteria? What is the marks distribution?
Oh yeah,
So
that was mentioned. I'm just asking like
yeah,
what the project is gonna be.
so that actually they have not. They're deciding right now, actually. Okay, so as soon as that is decided, it will be informed. So one problem is that yeah, so it will be a maybe a 1 month or 2 months long project in Kaggle. Okay, it will be a Kaggle, that is for sure. And what else? What else can I say? It will be so one thing which we are trying to which is a very important thing for us is that whatever sir taught, based on that only the problems statement can be solved. Okay, that is a very important thing for us. So nothing out of syllabus should be there again. And also we are trying to take care that I mean, it should not happen that as you know, I think maybe that in many of the Kaggle competition, what happens is that the students may apply some very high standard deep learning method or something, but that is not, that won't be allowed. Okay, that won't be allowed, and it should be I'm not sure whether it will be regression or classification, that we have to check. But yeah, so we will anyway try to accommodate whatever sir taught. Based on that only, the project should be solved.
So this problem statement will be set in by the IIT Madras team, right? Not something already exists.
I don't think so. I don't think, I mean, actually, see, they have not yet decided. They are just going through the problem statement and, I mean, judging the statements and making something now. But I think it will be uploaded by us, and not another program, not another something which is already there. Okay, yeah, people apply meetings, so there will be 2, 3, 4 milestones which you have to attend, and so there will be and based on that, based on the leaderboard on those milestone dates or something, you will be marked. Okay, so yeah, and apart from that, the once the final problem statement comes, then you will be then we can tell you more. Okay, yeah, so that is one major aspect which is still remaining for us. Yeah, and we will inform you about that. Anything else? Any other question? Okay, okay, just let me know if any other thing is there. So one thing which is remaining is the Kaggle competition. Kaggle statement will come out. That's not a worry. I mean, I think this week they will decide something and will upload it. Just let's see when they finish it. And another thing is the quiz one happening this week. So quiz one, do not worry too much. Just go through the search slides and search videos. Okay. I know. I mean, today morning only one announcement was sent about the MLP collabs. Okay. So anyway, we will go through the collabs. Obviously, this session now. Okay. In case you need anything, you can just take a screenshot and let me know in discourse also if you face any issue, if you need any particular portion of the collab, anything from week 1 to week 4. Okay, we will. So week 1 you can tag separate people. Okay, so week 1 you can tag Anamika. Week 2, 3 you can tag me. My name is Devajyoti. You can tag me. Week 4 you can tag Jimmy. Okay, so we have taken the live sessions in these 4 weeks. So in case you need anything, you can just tag us in the session, and you can in the discourse, and you can just ask for the collab part which you need. Okay, we'll try to accommodate. We'll try to update the collab portions or the codes which you require. Okay, so I think maybe I have shown in the live previous sessions also, the week 3 sessions also, we have shown the data preprocessing, data visualization, all those some portion of the collab was hidden, which we have shown. So if you need, you can see in the previous session videos also, and anyway, and take a screenshot or something like that. Okay, anyway, let's start with the week 5. We'll take the week 1 quiz 1 session, revision session also, so that I can't tell right now. I mean, that is not yet decided when to take, because there are two issues. One is the Saturday session is very near to Sunday quiz, so we don't want to disturb you on Sunday, on Saturday. Saturday is, I mean, your study should be for your study, and also we have a network issue on in IIT on Saturday. So anyway, we'll try to arrange some other date, and we'll see what I can do. I mean, it may happen that it ultimately falls on Saturday again, but we'll try not to keep it on Saturday, and let's see. We'll inform in advance. Okay. Anyway, let's start. So classification functions are taught in the scikit-learn. So sklearn APIs, cross validation, hyperparameter, and it has ended with a mixed data set, right? So he has mentioned two types of APIs. So one is generic, which has SGD classifier, and then specific. Among specific, there is a ridge classifier, there's perceptron, and other things. All sklearn estimators for classification implement a few common methods Scalar estimators for classification, they implement a few common methods for training, prediction, and evaluation. So one problem which may come is that many of these are keywords which are coming from the directly from coming from the Sklearn manual itself. Okay, and many of the code snippets are also directly maybe directly copied from there. So the best way to know more about them, if you so like I today we were answering a question on refit and all. Okay, so the best way to answer them will be to go through the scikit-learn manual, and I mean that is the best part. But also there also I have seen that all or many often much are not written. Okay, much are not written. So then in that case you can go through user guide, which is also provided in the sklearn manual. If it is not there, then I think we have to go to the I mean relevant paper which is there. Okay, and also if you can get working examples for the corresponding keyword, that will also be a good way to understand. Okay, so anyway, for model training we take fit xy. For prediction we have predicts class level for samples. For prediction we have these two keywords: decision function, which predicts the confidence score, and prediction we have predict x, which predicts the class level. And for evaluation we have score, which returns the mean accuracy on the given test data and levels. So mean accurate score function, it returns the mean accuracy on the given test data and levels. Then there are a few common miscellaneous methods. These are may not be that much important, but still there are sparsify, which makes a sparse matrix, again densify, which makes in a dense array format, and so on. Okay, get parameters, which may be a little relevant. Get parameters, it gets parameters for the particular estimator, and so on. So let's start with reach classifier. Reach classifier may come in quiz 2 again. Least square classification with reach classifier. So reach classifier is a classifier variant of ridge regressor. Ridge regressor again may come in binary classification. Classifier first converts the binary target to -1 to 1, and then treats the problem as a regression task. So classifier, what does it do? It converts the binary target to from -1 to 1, and then treats the problem as a regression task, optimizing the objective of the regressor to be somewhere. So we have to check. And it minimizes the residual sum. So this may not be that, this formula may not be that much important, but still you can check it, remember it, but not just remember what does actually reach classifier do, and I mean that should be good enough. Then there is something called multi-class classification, which is treated as mainly a multi-output regression only. Okay, and okay, I can't see, 1 minute. Yeah, so multi-class classification is treated as a multi-output regression only, and the predicted class here corresponds to the output with highest value. So in multi-class classification, the predicted class corresponds to the output with the highest value. Corresponds the predicted class is the output with the highest value. Whatever is the highest score which is obtained, according to that the class is predicted. Okay. Then okay, from here it may be important. So what they may ask is how to train a least square classifier. Okay, so you instantiate, first step is to instantiate a classification window. See, basically what you will be asked is, you will be asked which is the which is the way to instantiate the classification estimator. So you will be given 2-3 options. So one of the option will be this one, that from a Sklearn model import reach classifier, and reach classifier one variable will be defined equals to reach classifier, and so on. And then the step 2 is to call fit method on the reach classifier object with the feature matrix and level vector. Okay, And then basically you have your X train and Y train. So you have rich classifier dot fit is fitted with X train and Y train. Okay. But mostly we try to give the first two lines. So from sklearn.lin. So remember which library it is working on, and also in your OPE it will be required. I think that from it will be good to remember from which library we are importing rich classifier. So that will be helpful, and then this is okay. This you can remember that how to set the regularization rate. So how to basically set alpha. So just remember that the regularization rate is denoted by alpha. Alpha is a float value and the default is 0.1. So mostly in your OPE exam, it will be given that rich classifier, make a rich classifier with alpha equals to 0.001, or if it is tried to be more difficult, then set regularization rate to be equals to 0.001, and carry on with the given task. So then you have to just put regression in classifier equals alpha equals to 0.001. So alpha always should be positive. Okay. So that is again one mark quiz question. They may ask that whether alpha is a positive or not. Give a true false, something like that. Okay. And larger alpha value specify stronger regularization. Then there are different optimization solvers. You have sir has taught about that Kolsky, Sparse, and SAG, LV, FGS, and sir has described all of those things. So yeah, how to make rich classifier, select the solver automatically. So these portions, these small code snippets are important. I would say that try to write those, and how are those being used. So like what is here used, how to make rich classifier, select the solver automatically. So if you just put the solver equals to auto, then all the things are taken care of. So the default choice for solver is auto, and if you see there, what is the solver? So these are the solvers present there. So SVD is there, Sparse CG is there, LSQR is there, list square, then SAG, Saga, LBF, and so on is there. Then auto, we have auto. If solver is equals to auto, then return intercept, solver equals to same. So anyway, the default choice for solver will be auto. Okay.
What
That you
is
can,
basically, sorry to interrupt, sir. So what is basically the function of the solver?
So solver solves these optimization problems in the rich classifier. Okay. So whatever optimization it needs to be done, that is required by, that is solved by, used by the solvers. Okay. So let's see whether I can find some details more in sklearn. Rich classifier, right? So here you see the solver is equals to auto. Okay. So generally, I mean the default is auto. So solver to use in the computational routines. So auto chooses the solver. 1 minute. Chooses the solver automatically based on the type of data. SVD uses a single value decomposition of X2. So basically, to find the different coefficients of rich classifier, these things are used, right? So SVD uses a singular value decomposition of X, and most stable for singular matrices. Kolsky uses the linear algorithmic function to solve a closed form solution, and so on.
So basically,
Let's see more.
how do we select the solver? As in, suppose if I have a data set, and how do I select a particular solver for that data set?
So for large scale data, you should use the Sparse CG solver. And if your number of samples and number of features are also very large, then sir has suggested to use SAG or Saga solvers. Okay.
Okay.
So
it is
yeah.
Yeah,
based
so
on
it
the
is
data
based on
state.
these, based on these parameters, right?
Yeah,
Sir?
Yeah,
But
obviously.
since auto selects automatically based on the type of the data, is it so that auto is selected generally whenever we do
Auto is the
classification?
default. Auto is the default. Auto is the
Okay.
default.
Yeah.
Auto is the default choice. Okay. So I think, I mean, we should not, I mean, we can just, for the time being, we can just keep it in the auto mode only. Okay. So I think that will be best thing. So auto chooses the solver automatically based on the type of data. So then we need not take in care of, need not to take care of it more. Okay.
Okay, sir. Yeah.
Yeah.
Yeah, hello. And Vijay, can you hear me? This is Amrita.
Yeah, sure, Amrutha. Yeah, so my
Yeah,
colleague
just,
Amrutha is here. Amrutha, please go on.
yeah, I just want to give an additional input on solvers actually. So this question is, why do we need a solver? Is that
Yeah.
Yeah, so solver is used for solving this optimization problem. So, for example, we have learned this gradient descent. Right? So, gradient descent, what happens? You need to find the minimum loss value. So, that is what our main objective is. So, when you want to have a model which gives you very less error, the motive is it should have very minimal loss value. So, how do we fix that minimal loss value? How do we arrive at that loss value? Just by finding the model parameters such that those model parameters will give you that minimum loss. So how do we arrive at those model parameters? Is through these solvers. So these solvers help you to solve this optimization problem, which in turn is to minimize the loss of the model. So that's it. So the parameters that we need to achieve this minimum loss is what is achieved through this solver. So there are a variety of solvers available. So simple is, if you can understand easily, that is a stochastic gradient descent solver. So because we have learned the stochastic gradient descent mechanism in different techniques course also. So that is why we use these solvers.
Yeah. Okay, ma'am.
The doubt is clear.
Yeah. Yes, ma'am. And ma'am, so when we are using solver, do you again use the hyperparameters testing? I mean, do we use that, or the solver does the work?
The solver does the work. It finds you the parameters.
Okay, sir. Okay, ma'am. Yeah. Thank you.
Yeah, you can go ahead.
Yeah, sure. Thank you, Amrita. Yeah. So the default choice for solver will be auto. And so there are some other things which are taught. So if is intercept estimation necessary? So and if data is already in a centered position, then we can use fit intercept is false or true, so that no intercept will be used in calculations. And the default value is again fit intercept equals to true only. How to make predictions on the new data sample? So using predict method, of course. So this again may be important. So how to, they can just ask how to make predictions on the new data sample. So you can just say using the dot predict method. So how to write those? So y pred equals to reach classifier dot predict. So you have to call predict method on the classifier object with the feature matrix, which is the given feature matrix for you as an argument. So you can use that, and we can write the we can write the prediction on the new on the data samples. Rich classifier CV implements rich classifier with built-in cross validation. So generally with built-in cross validation it will work on. Okay, fine. Else let us see what else is there. Okay, so for perceptron is a classification algo suitable for large-scale learning, like MNIST dataset we are using it, right? So and it shares the same similar implementation with SGD classifier, and it uses SGD also for training algo. Okay, and how to implement perceptron? So we have to instantiate a perceptron estimator, and how do we implement perceptron? That also will be important for OP, I think. So from sklearn.linear model we import perceptron. We call fit method on the perceptron's estimator object with the feature matrix and level vector. Okay. Then there are some parameters which are given. So tolerance level is there, maximum number of iteration, fit intercept, etc. is given, which I mean, yeah, obviously we will face it in our in our exams, or exams means OPs and all. This will be just given to be, so just keep maximum iteration to be equals to this much, or keep the early stopping criteria to be true, or keep the penalty, whatever is the penalty. So L1, L2, and whatever other penalties are possible, we can keep that, and so on. Okay. And with that, we can implement the perceptron classifier. Now, perceptron classifier will be trained in an iterative manner with partial fit method, and it can be initialized to the weights of the previous run by specifying warm start equals to true. So that also, I think, sir has mentioned. Sir has mentioned in the videos. It can be, perceptron can be initialized to the weights of the previous run by keeping warm start equals to true. Achha. Other than that, we have logistic regression classifier, which uses the logistic regression API. So logistic regression classifier, again, regression API, it implements the logistic regression classifier. It has some other names, and it can fit one versus rest, binary classification, and multimodal or multinomial logistic regression. But let us see what else is important here. So again, these portions may come, these code snippets may be important for you, that how to train a logistic regression classifier. You have to instantiate a classifier estimator, and you have to fit it on the training set. Okay. So again from sklearn.linear model, we import logistic regression, right? So let us see where else did we import the reach classifier from. If we go to reach classifier, see, this is also from sklearn.linear model reach classifier we are importing. And here also from the sklearn.linear model we are importing perceptron. So both perceptron and reach classifier is from sklearn.linear model. Fine. Then logistic regression, this is also from sklearn.linear model. We import logistic regression. So all of these three, right? Logistic regression, perceptron, and reach classifier, all of them are from the sklearn.linear model library. Then
sorry, sir. Sir, when we do, there was a thing called partial fit. So that is used instead of the fit function here, is it? Like logic underscore classifier dot partial fit is what we do when we do that. So in the previous slide it was there. I think it was in Ridge, I think, probably. Yeah. Next slide, sir. Yeah, here. The perceptron classifier. Yeah. So do we do it the same way? Dot partial fit.
Partial fit method. I'm not sure. I have to check. Amruta, any idea? I think she's may not be there. Okay, I'll just 1 minute.
Yeah, we can use that partial fit.
Yeah, we can use partial fit method, right?
And it happens in iteration in the sense that it takes a couple of data points and then does it over and over again. Is that what it does?
Partial fit means when the data set is large. Currently, in real world scenario, we have large number of samples. At that time, we use this partial fit so that we can consider the branches of this.
Your voice is not very clear. Sorry.
Maybe Amruta, you can write in the chat window also if you wish.
Okay.
Yeah, now it is coming clear. Amruta. Oh, okay. Okay, sure. I mean, yeah.
That's why the reason is we are using for partial and type the chat window.
Okay, sure. Yeah, so Sunita, just see in the chat window she is typing.
Sure, sir. Yeah. Thank you.
Okay, yeah, sure. So I mean, mostly these things are there, and what else? Then there is SGD classifier again. So this also, so it is an approach to fit linear classifier under convex loss function, etc. So the API uses SGD as an optimization technique. It can be applied to build a variety of classifiers by adjusting the loss parameter. Okay. So here one thing is important, and which will surely some questions somewhere will come, is the one versus all and one versus rest. Something may come. So it supports multi-class classification by combining multiple binary classifiers in a one versus all scheme. Easily scales up to, yeah. So Amruta has answered, partial fit is used when the data set is huge and does not fit into memory as a whole. Okay. Thank you, Amruta. Thanks. So, and also it easily scales up to a large scale problem with more than 10 to the power 5 training examples and 10 to the power 5 features. SGD classifier also works with sparse matrix and sparse machine learning problems. And the general application areas are there, which are NLP and all. Okay. Then we have different loss functions, loss parameters, which are used in with SGD classifier, right? So one is a hinge loss, which is used for linear SVM, then log, which is logistic regression. Huber loss is there, so modified Huber loss is there, squared hinge. So these are all different types of loss values, loss parameters. I don't think, I mean, there will be more questions asked on what are those and all those things, but obviously the best way to learn more about them will be in the skill manual, okay, and the relevant user guide. So different, these are the different different types of loss parameters which we can give in SGD classifier. And what is the default value? Obviously the default value is hinge loss. It trains linear support SVM classifier only. So if you see what is the hinge loss is the linear SVM classifier. Okay. So let us see whether we have more details on SGD classifier here. Hinge gives a linear SVM. Log loss. So these are the also it's on different checks. Okay. Thank you, Amrit. Log loss gives logistic regression a probabilistic classifier. Modified Huber is also another smooth loss that brings tolerance to outliers. Squared hinge is like hinge but is quadratically penalized and so on. Okay. And again, as I was talking, that more details about the loss formulae can be found in the user guide. So this will be the best place to check. Okay. So like hinge loss, this is the SVM classification of hinge loss. So these are the, okay. So there are different choices of loss function. So L is the loss function that measures the model misfit, and R is a regularization term, and so on. So different formulae are there for different loss function. Just remember for the time being, what as far as sir has given in the slides, hinge is the default. Hinge gives a linear SVM. Okay. Let's see whether hinge is there. Yeah, so loss equals to hinge. Okay. And how does SGD classifier work? This also sir has told that it implements a plain stochastic gradient descent learning routine. So the gradient of the loss is estimated with one sample at a time. Then the model is updated along the way with a decreasing learning rate or strength schedule. So basically the loss gradient is estimated along with one sample at a time, and then the model is updated, okay, constantly. So there are some advantages and disadvantages as well. So the advantages has efficiency and ease of implementation. Disadvantages have it requires a number of hyperparameters and so on. Then there are different instantiating of SGD classifier for training a classifier and so on. How do we fit a method on SGD classifier? This will be also important that because SGD is anyway hugely utilized in our course and all. So sorry. So for that purpose, remember that how the where is it imported from, and how what we can so mostly in OP it will be given that what keep the loss value as log, or keep the loss value as default or hinge or so on. Okay, so the and the corresponding fit application will be relevant there. uh, okay, next is so what are the errors which are possible, what are the penalties, sorry, not errors, penalties which are possible. So one is L2, which adds a L2 penalty term. L1 will be a so three types of penalties are possible. One is elastic net, one is L1, and another is L2. Okay, default will be L2. Yeah, sorry, I just got disconnected. Sorry, guys, I just got disconnected. 1 minute. Can you hear me now? Amruta, can you hear me now?
Yeah, I can hear you.
Yeah. Sorry, I mean, there was an internet issue. This BSNL, na, always some problem. Okay. Anyway, so the common parameters between classifier and regressor. So there are again different criteria which is given. Learning rate and whether you want to use the previous turn result only, settings only. So you can give 1 star, true or false, and so on. Okay. So again, the first summary. So what did we learn? We had reach classifier, perceptron, and logistic regression. All of them are imported from the same library, right? And we can use also SG. So we learned how to implement these classifiers. List square is implemented by reach classifier. Then perceptron is there, and logistic regression is there. Alternately, what we use is a SGD classifier with appropriate loss function. So loss we can keep as squared error loss for list square, then loss equals to perceptron for perceptron, and loss equals to log for logistic regression, right? And there are a few common methods to implement, like feed, score, decision function, and predict also for predicting the outcome. And apart from that, sir has taught about multi-class and multi-level, which again we will go through in the MNIST also. Multi-class has exactly one output label, and for more than one output label, what is there are two types of classification models. So one is multi-level and another is multi-class, multi-output. Okay, so multi-class classification has one output label, exactly one output label, and the total number of labels is greater than 2. For more than one output, there are two types of classification models. One is multi-label. If there is more than one output, so if it is exactly one output, then there is multi-class classification. If there is more than one output, then there are two types of classification models. One is multi-label, where total number of labels equals to 2, and multi-class multi-output, where total number of labels is greater than 2. Okay. So both this multi-level and multi-class output, multi-class multi-output, we are treating as multi-level classification, where the total number of output levels is greater than 1. Okay. So again, so sklearn provides a bunch of meta estimators and which transform the multi-learning problem into a set of simpler problems. So again, so we have multi-class classification, which comes from sklearn.multiclass. It has some classifiers. Okay, one is 1 versus rest, 1 versus 1, and output code classifier. And for multi-level classification, so what is multi-level? Again, multi-level is total number of level equals to 2. And for multi-class, we have multi-class classification, we have number of levels is greater than 2. Okay, and for multi-class multi-output, we have total number of levels greater than 2. So multi-level classification, we have multi-output and classifier chain. And we have inherent multi-class as 1 versus 1, 1 versus rest, and so on.
Sir, in the previous slide, in that multi-class and multi-label one, why is it restricted to equal to 2? Why can't it be more than 2, the multi-label?
1 minute here. No?
Yeah, here, sir. Multi-label total number of labels equal to 2. Why can't it be more than 2?
So why is the 2 value important?
Yeah.
Let us let me check. 1 minute. Huh? Amrutha, any thoughts? Amrutha?
Hello? Can you hear me?
Yeah, we can hear you.
So mostly in the multi-label classification, labels are considered to be 2.
But in multi-label as well, there could be multiple labels, right? More than 2. I mean,
so far I have seen that it is still unknown. So they have 2 classes and then a label. It is either 0, 1 or 1, 2 or something like that was given.
Okay.
That's why we have done it like that.
And when we say multi-class, ma'am, within those 2 labels itself, we have multiple classes. That is what it means, right?
Yeah, multi-class.
Yeah.
So yeah, let us just get back to you. Okay, that is a nice question actually. Why 2? We have to, we'll check once. Okay.
Yeah. Yes, sir.
We'll just check one. Let us get back to you. I'll post. Maybe I'll try to post on Discourse. Okay.
So I'll try to put it on chat also. Continue the session.
Yeah. Okay. Okay. Sure. Sure. That will be great. That will be great. Okay. Let us show the collab also, because that is also important. What else is there? So basically, this multi-class and multi-level only sir has talked about, and then there is 1 versus rest classifier and 1 versus 1 classifier. Okay. So you can just go through the slides there, and I mean just note, okay, how this thing is working and all. Okay, so one is one important thing here is one very crucial differentiating point. So these are the different multi-class classification strategies which are implemented in sklearn. One is 1 versus all and or 1 versus rest, and another is 1 versus 1. So 1 versus 1 and 1 versus rest. Okay, OVR and OVA. Now, the important thing here is, so this approach requires only key classifiers. Okay, so whatever is the number of classifiers, that is only required. And here in 1 versus 1, the total number of classifiers is KC2. Okay, just wait, this I will just check once and get back to you. So OVA and OVR, 1 minute. 1 versus 1. Let me see whether I can give you some more details. Okay, so 1 versus 1 multi-class strategy. So this strategy consists of infitting one classifier per class pair. At prediction time, the class which received the most votes is selected. Since it requires to fit in classes into in classes minus 1 by 2, this method is usually slower than 1 versus the rest due to its order of in classes square complexity. However, this method may be advantageous for algorithms such as kernel algorithms, which do not scale well with number of samples. This is because each individual learning problem only involves a small subset of data, whereas with 1 versus the rest, the complete data set is used in classes times. So just learn what are the different values, what are the different features of it. Okay, of what is the difference between 1 versus 1 and 1 versus the rest. So 1 versus 1 consists of fitting one classifier per class pair. And at prediction time, the class which received the most votes is selected. Let me see whether some more thing is there. So here we construct one classifier per pair of classes. Okay, and in 1 versus rest or 1 versus all, in fitting one classic, here also one classifier per class. Yeah. Amrita? Yeah, go on.
So actually, what you're trying to say is the difference between 1 versus 1 and 1 versus rest.
And 1 versus rest. Yeah.
See, 1 versus 1, what happens is this is a multi-class classification. So there may be many classes. So for example, if you take 3 classes, class A, class B, class C. 1 versus rest, what happens? You consider class A versus all the classes clubbed into one class. So that is 1 versus rest. So that is the basic difference between 1 versus 1 classifier and 1 versus rest. So just imagine how many number of classifiers you will need if you are going to consider between all the pairs. Okay, but what happens in 1 versus rest? It is simply for the number of matches. So that is where the complex is. Between 1 versus 1 and 1 versus rest class.
Audio is not clear, so we are not able to hear properly.
Oh, audio is not clear. So
there is
later
background noise.
Yeah, no, actually some that background TV noise is coming up. Yeah. Okay, yeah. Okay, we'll come back. We'll come back to Amrita and ask her. Yeah, Amrita, are you there?
can you hear it now clearly?
Yeah, now we can hear you. Yeah, it's better. Yeah.
Is it audible? Okay, not clear. Still not clear. Hello?
Yes.
The background noise is taking over your voice.
Sorry for
Okay,
that.
Amrita, you can put in the chat window maybe.
I'll type the difference. You carry on.
Yeah. I'm sorry. Sorry, we could not hear you. Yeah.
Okay, we'll find some other place.
Yeah. Okay. Yeah, I'm sorry. We'll put in the chat window, guys. Okay. Anyway, yeah. So go through this. I'll just post this link also in the chat window. Okay, this I think will be helpful. And apart from that, these are not very classifier chain is not that much. Yeah, Amrita, please go on. Okay, you are on mute. Sorry, you were telling something. Okay. Okay, sure. Okay, so anyway, these slides anyway, it is uploaded in the in the slide deck in the in the supplementary material. So please go through the slides once and go through the lecture and the skill manual also. That will be helpful. Apart from that, yes. So this again we have discussed. So refit. So logistic regression CV is used. So it supports inbuilt cross validation strategies. Okay. So logistic regression has one parameter called refit equals to true or refit equals to false. So the
Sir,
refit,
I
what
didn't understand the difference between both the refits. They sound the same, sir. I mean, whatever is written there, the scores averaged across folds, and even the other one is folds are averaged. So I couldn't identify what is the difference between the two.
yes. So I think so. See, I also whatever we understood is that I mean, see at one place scores are averaged across folds. Then values corresponding to the base. So at first it is averaged. Okay. I think the difference, I think it may, my understanding till now what I understood, okay, that there is the difference is in order. Okay, see in the refit equals to true, the averaging is done in the first step. So scores are averaged across folds, and then the best score is selected and the and refit with those parameters only. Here, if refit equals to false, what is happening that the intercept and C which correspond to the best scores across the folds are averaged. So at first, the best scores are taken in refit equals to false, and then they are averaged. Okay. So that the difference is what I have understood. What I understood is that it may be the difference is in the order. Okay, in one place in refit equals to true, the averaging is done at first, whereas in the refit equals to false, it may happen that the difference is in the averaging is done at last. But again, this up to here was given in the sklearn manual. Okay, I think Shreya has we actually discussed this same thing, this question in the same question you asked in the discourse today. So she posted a code to understand the numerical difference between refit equals to true and refit equals to false. So please go on.
Yes, so I'll check on discourse then, sir.
Yeah, just once check what is the difference. I'll also check because it may happen that I am not I have to check correct my explanation also. Okay, so just check what is the let me see whether I can find the discourse post also. 1 minute. Huh? One minute. Yes. Yes. So we have to. Okay. Okay. Let's you could run. So this is the post logistic regression. Refit equals to true. Refit equals to false. Right. Yeah. So up to here was mentioned. Whatever we put there, that was mentioned in the sklearn manual. Okay. Now let us see what Shreya has taught. You could run this code, which is a numerical example of how CV works. Okay. Okay, let's run this code once and see how what is happening. We'll try to understand it. Okay. Let's go to a new notebook. I'm sorry, it's taking a long time. Import numpy as np. Let's see. Create a simple classification dataset from sklearn.datasets. Import make classification. Data labels make classification in samples equals to 30 and features equals to 3. So number of classes equals to 2, and there is no redundant class. So from sklearn.model selection, we import train test split, then train test splitting 80:20. Okay, fine. From sklearn.linear model, we import logistic regression CV. LCV, the logistic regression CV with refit equals to true. Okay, so this is case 1, repeat equals to true. LCVR equals to logistic regression CV. Repeat equals to true. LCVR dot fit. So we are fitting on the data set, toy data set on, and then we are calculating the scores returned by the estimator. And so LCVR dot scores and dot mean access equals to 0. This is the average of the scores used to determine the best C value and what is the C value actually selected. Fine. Then case 2, train logistic regression CV with repeat equals to false. Here LCV is the same thing, C range, CV equals to 4, repeat equals to false. LCV dot scores represents the scores returned by the estimator, and index equals to LCV dot scores 1 access equals to 1. That is the same thing, right? Best scores across each value. So scores returned, then they have calculated best scores, then averaging the C values corresponding to the best C value in each force. So basically that is the thing it looks like. Okay, Sunita, so basically the procedure is different. So in repeat equals to true, we are calculating the average of the scores to determine the best C. So let's see. So here it may not be the full case, right? So here the answer is an array value with 0.1. Okay, so the answer is here it comes 0.1. And if we put repeat equals to false, case 2, then what is it comes? Sorry, where we were doing untitled data set, right? So here the output is separate, it is different. So here it is coming 0.01. So basically it looks like, Sunita, the procedure for both fitting, for both logistic regression will be different for repeat equals to true and repeat equals to false. Okay.
Yeah, sir. The first one, I think it averages and then picks up the best one. And here
Yes,
it picks
yes.
up few best and then averages out of them, I think. That's basically
Yes,
the
yes.
difference, I think.
Yes. So here also, if you see, yeah, actually this is copied from the manual only. So if you go 1 minute, just go to the repeat.
So could you please pass me the link to that discourse, this link, I mean.
Yeah, 1 minute, 1 minute. Okay, sorry, I came back. Well, okay, I'll go back and pass you. Okay,
Yeah,
minute.
sure.
Let me, yes, if set to true, the scores are averaged here at first, and in other case, so this is for default equals to true. For repeat equals to true, then the scores are averaged at first, and otherwise the everything is done, and then the best scores are averaged out and so on.
Yeah. Okay, sir. Yeah.
Yeah, I'll post the link. 1 minute. I think this is the link. Should work. 1 minute. Yeah. Okay.
Thank you, sir.
So yeah, sure. So that's that. And what else is there? So some of those metrics are there, and the confusion matrix again. Anyway, we have studied. So import confusion matrix. It evaluates the classification accuracy by computing the matrix with each row corresponding to the true class, right? So confusion matrix display, with confusion matrix display, we can display the confusion matrix. And what else? And we can we can make the classification report as well, as we have done in the week 2 also, right? We have done the this confusion matrix, and we can get the classification report as well. So mostly those things are there. Okay, just check. Let us know if any other thing is any other code or anything is required. We'll go to the collab now, and we'll go through the collab slowly. This is MNIST Perceptron. So I think only one collab was used by sir in the full program. Okay, full the lecture videos. that is MNIST, this one only, MNIST classification. So as you can see, so we will be considering image classification, and in week 6 we are we'll be dealing with naive bias. So here we'll be dealing with image classification and solve it using perceptron model. We'll import the necessary packages for classification model. We need to import the classes and utilities from sklearn.linear model, and first import everything required, whatever is required, numpy, snp, OS, IO, warnings. Then sklearn.datasets we are importing fetch OpenML. Then min max scalar. 1 minute, just 1 minute. Let me get back to you. Amrita, just 1 minute. I'm facing some network issue. I'm coming back. 1 minute.
Yeah, okay.
So import from sklearn.datasets, import fetch OpenML. From sklearn.datasets, we can import fetch OpenML, and we can utilize min max scalar, and then there is dummy classifier, pipeline, and perceptron. Everything we import, and confusion matrix display, of course, and so on. Then we can import precision score, recall score, and matplotlib, matplotlib pyplot, and then seaborn. Everything we can import. Okay. Achha. And we have defined a random seed also. Now this is not required, but we are just suppressing the warnings to not to see the warning messages. Now what we are trying to do is we are doing a handwritten digit classification. So here we are trying to use the perceptron classifier to classify or recognize the given digit images. Okay, since a single perceptron could only be used for binary classification, we consider only 2 classes in the first half, and we extend it to multi-class settings. Now we want to recognize whether the given image, so one particular handwritten image, is of digit 0 or not, or something other than 0. Okay, so therefore the problem can be used as a binary classification problem. So one thing which we can do is we can use as a binary non-binary classifier, right? So we can check for multi-class settings, so maybe 0, 1, 2, 3, 4 up to whatever, up to 9. And then what we can do is we can try to recognize whether the given image is of digit 0 or something other than 0. Okay, if we are trying to classify as 0 or not 0, then the problem is a binary classification problem. Okay, now we have the data set for that, which is the MNIST data set, right? And so if we import the data set, how do we import it? X comma y equals to fetch OpenML, right? Fetch OpenML. Then this is the name MNIST 784, and return xy, return underscore x underscore y equals to true. It returns the data and label as a pandas data frame. Okay. So the data matrix X and the respective label vector will be converted to the NumPy array by calling two NumPy methods. So X equals to X dot two NumPy and Y equals to Y dot two NumPy. Let us also run the codes. Okay. 1 minute. I think we can do a run at the same time, right? Run on. Okay. So we can just go through. What we can see is xy is equals to fetch OpenML. So we have fetched the OpenML dataset, the MNIST dataset. Then what we have done is we have the level vector y, which needed to be converted to NumPy array by calling the to NumPy method. Okay. So what happened is we have x equals to x dot two NumPy and y equals to y dot two NumPy. Then we observe that the labels are of string data types, not integers. Okay. So at first we have the target names, which will be np dot unique. We can calculate. We can get the target names by putting np dot unique. Then we print what are the number of samples, the number of features, what is the minimum and maximum value, what is the number of classes, and we can put the labels. Okay. So let's wait. Sure. Thank you. Okay. Okay, so this collab may take about 5 to 6 minutes to execute. So just we'll come back 1 minute. Or we can do one more thing. Let me 1 minute. Huh? Yeah, so as the previous collab is taking some time, it will take some 5 to 6 minutes to run properly. So I have just opened a new window. Okay, so as you can see, we have a number of samples to be 70,000 and the data type is mostly float. Okay, so and we have 784 features and minimum is 0 and the maximum size is 255. 10 classes are there. So what are the labels that we have? We have 0, 1, 2, 3, 4, 5, 6, 7, 8, 9 only. Okay. Now the MNIST data set is clean and the range of values that the features can take, that is also known. Therefore, the samples in this data set may not require many data preprocessing techniques. So MNIST is a standard data set, does not need much better preprocessing. But still what we are doing is we are scaling the range of the features between 0 to 1. Yeah. Amrita, please go ahead. Sorry.
Devjit, I just want to ask them the question that in MNIST dataset, it is an image, right? So do they know the size of the image of a single data sample?
Yeah, so can anyone please answer?
Anyone answer what is the size of the image? Because as Devjit told you, that is an image data set. So you must need to know that size of an image, right? Because an image is in a grid format with rows and columns. But here it is given as a number of features, 784. Can anyone answer that question? What is the size of an MNIST image?
I think only two people are there, Bhupesh and Kanika.
Hi.
Is it in?
Okay, so actually the size of an image is 28 by 28. So it is a grid format. So what happens in this data set is this image is flattened into a vector. That vector, that is 28 cross 28, is equal to 784. So that gives you the number of features, which means each and every pixel of that image is a feature. So that is what is considered in our data set. And that data set, a pixel value is 8 bits. So in 8 bits means it's a, if you expand it, it is 256 actually. So that's why the values are from 0 to 255. Yeah.
It's a grayscale image, basically.
It's a grayscale image. Yeah, that's what gray levels are, 8 levels of gray. So that's why we have this value 0 to 255. Yeah. So this is an image sample, right? So that is what I wanted to make sure. Yeah, you carry on, Deepjit.
Yeah. So I think we should make this session more interactive as so less of us is here, maybe all of us. Would you like to switch on the video and anyone would like to switch on the video and talk maybe? We can make it a little more interactive then. So less people are here. Yeah, hi Bhupesh, 1 minute. Yeah, Bhupesh is here. Amruta, would you like to switch on the video? Or I don't know whether Kanika is there. Okay, I think Amruta is on mute or somewhere. Anyway, so Bhupesh sir, where are you from?
So I am currently in Mohali, Chandigarh.
Acha, nice. Okay, nice sir. And what do you do? How do you?
So I am like I have 20 plus years of industry experience. I am in software development, and
How nice sir. How
taken
nice.
a sabbatical to pursue this course because it was not possible to do it while doing the job. So I have taken a sabbatical to pursue this course.
Oh, that is very interesting. Very interesting. Thank you. Amruta, would you like to switch on the video? I don't know. Are you? Will you be able to? I'm not sure. Where is she? Okay. And yeah. So Kanika is also here. Kanika, how are you?
Hello, hi sir. I'm good. How are you doing?
Yeah, I'm. So we are a lot of pressure to arrange the Kaggle the MLP projects and the what do you say, the OP and OP papers and OP papers mostly. Yeah. We won't yeah. So any thoughts on any questions on the on whatever is going on, the quiz one, the copy one, the Kaggle, anything, any doubts?
No, kind of afraid for that Kaggle competition, but that will be interesting.
Yeah. So
Challenging.
we are also we are also trying to make it. So we will and we know, I mean, it is being a problem for if we are not providing the collabs, that's getting difficult. But I mean, it's a decision taken, so we'll follow it. We'll inform everything. We will update everything in the live sessions. Okay, just let us know any particular portion you want to see or something like that. Okay, we'll show it. That will be at least we'll try to help as much as possible. And so best of luck for the quizzes and all everything. So it will be easy. It will be easy. Don't worry. It will be easy. I mean, we prepare the questions so that there is no should not be difficult. It is a high scoring paper, and all questions are 2 marks, 2, 3, 4 marks. 4 marks is not there. I think 4 marks is not there. Mostly 2 marks questions. So 2 marks means MCQ only. MSQ may not. There are some MSQs, but like 2 different ways to instantiate something and so on. Okay, so should not be that much difficult. I think all will be okay. Just go through it, and that will be helpful. Amruta, would you like to say something? I'm not sure whether Amruta is there or not.
Hello.
Yeah, Amruta. So we were chatting. I mean, Mr. Bhupesh and Kanika is there. We are so less number. So we thought we'll switch on the video and have a chat. Would you like to switch on the video? And Amruta has a PhD in image processing, and she is going to handle the deep learning next term. So yeah.
Oh, great.
Yeah. So anyway, okay, let us continue. Yeah, sure. We'll not waste the time. Yeah, obviously. Yeah. So anyway, let us, you can switch off your video, sir, no issue. Please feel free. Okay, so anyway, the MNIST data set is quite clean, and it does not take any data pre-processing. So we can use a min-max scaler or max absolute scaler. They do not make any difference as the pixels cannot take only positive values from 0 to 255. So what we can see is the min-max, we have used here min-max scaler. And then as Amruta was also telling, so we are taking few images. So the images is stacked as a row vector of size 1 by 784, and we are reshaping it to 28 by 28 size. Okay, we are trying to display them properly. So this code is used to display the some of the images. We have 28 by 28 size. So you can see 5 is.
If I want to determine the size, do I need to use some software to check the size of the image, or it will be mentioned in the data set?
It will be mentioned in the data set, and also MNIST is a very standard data set, sir. So should not be much. And these are the number of features mostly. So no other software will be required.
In real world, there can be images with different sizes also, right?
Yes, that should be there. It can be there.
So in that case, the number of features will vary. Like we have to take the maximum, like the maximum size as the features, right?
Yes, we have to take the maximum number of features.
Okay.
I didn't. Yeah. So I mean, no, I don't think any other software will be required. Amruta, any thoughts?
No, actually, if an image is given, no, the image shape you can find from a single example. If your data set consists of image, you can load that image and then you can find its shape. If you load it in a NumPy array, you can easily find using this Python also. But here, what the reverse is happening here, we have given the features in a row vector. That is, we have expanded the image in a row vector. Each and every pixel is arranged like that, if you consider. So that's why we have to, in order to show the image, we are reshaping it. That is displaying the image.
Okay.
Otherwise, we are not going to process any images here. We are only processing this features that is in the row vectors. They are only processed here. Images are not processed as such. We are passing it after flattening them into this original data set, which contains these row vectors.
Got it.
Yeah. Okay. So we can ask different questions. So is the data sparse matrix? What is the range of the pixel values and so on? Okay, you can see that there are moderate variations in the appearance. So at one place, one is denoted like this, then another person wrote one like this, another person wrote one like this, and so on. Okay, so these matrices are close to sparse matrix. There are lots of zeros. You can see 0 means the black pixels are 0. Okay, so in the matrix, then the non-zero pixels. So non-zero pixels are the white color ones, right? So as there are black, so what does this mean? That there are a lot of black color and a very less amount of white color. So that black color means the 0 values. So those are the sparse matrices. This is a sparse matrix, right? Because there is a lots of zeros there. And if you take one, you can actually understand. So this is a figure size which we are putting, and we are reshaping it to 28 by 28. And you can see this is one single image. It looks like this. Okay. Now we know the details such as the number of samples, the size of samples, and the number of features, number of classes. Okay. And we split the number of samples into train and test set into 60,000 by 10,000. Okay. So this is the normal ratio which we just took for our own understanding and so on. So there are 60,000 samples in the training set and 10,000 sample in our testing set of the images. Okay. And as the samples are randomly shuffled, we are not shuffling it again. So we are just doing a train test split, which may also be skipped. Okay. So we can remove a train test split as well, because we do not need to shuffle it. It's already randomly shuffled. Okay. So the next line of code will be X train and X test, and Y train, Y test. We are just taking up to 60,000. Okay. So what is the test set? So X from 60,000 to the remaining, and Y also from 60,000 to the remaining. right? So X test is X 60 from 60,000 to the remaining part, and Y test is Y from 60,000 to the remaining part. X and the train part is up from 0 to 60,000, and the other yeah, someone wants to say
How,
something?
yeah, how come it is already shuffled?
So it is randomly shuffled in the data set itself, sir. Okay. So that came with the data set itself.
Okay, okay.
I think, I mean, the as the images are like, I mean, not like properly organized. So that is what it is meant by, I mean, so properly organized means there is 5, then there is 0, then there is 4, 1, 9, 2. So there's a shuffling that is done. Okay.
But suppose if we take the data from the top rows, like it will always be black pixels only. And it will be binary. If we don't go to the middle part of the image, we just take from the top, then it will be just black dots.
So I think the data set itself, the samples in the data set, yeah.
It is.
Yeah, I think you're confusing between the samples and the image actually. So we are not talking of the image. So this is a single image, but what what Dave Jyoti told is the number
This
of
one.
samples in the image. Sorry, the number of samples in the data set.
So like 504 is one row, then 192 is one row, right?
Okay, okay.
So that is the
Yeah.
shuffling, right, Amrita?
Yeah. See, for example, here this is an image. So don't worry about this image. This image is for just visualization purpose. The data set initially consists of that training set is 60,000 cross 784, which means one row corresponds to one particular image. So that one row is reshaped to visualize as an image here. But what the original data set consists of, the first row, if you consider, that is corresponding to one particular image. So for example, label 5. And the second row will be another image, which is a label 0. And the third row will be of label 4, like that. So it is not in sequentially arranged. For example, like 1 to 100, 0 to 100 will be of label 0. And then 101 to 200 will be of label 1. So like sequential arrangement is not there in MNIST data set. That is what he meant to say.
Okay, okay.
Yeah, thank you. Thank you, Amrita. Yeah. Yeah, so apart from that, what else we have? So we have done up to 60,000 and from 60,000, right? So, and we can check whether the data set is balanced or imbalanced. So we do it by plotting the distribution of samples. So this is the plot. We are using a histogram to check the data set, right? And so you can see the distribution of the samples. So we have, these are the zeros. There are around almost 66,000 zeros. Lot of ones are there, more than almost 7,000. 2 there are up to 6,000. Then a little more is 3. Then a little more is 4. 5 is also there, and so on. This is the distribution of the samples in the data set. So that we can classify from 0 to 9. Okay. Achha. Now we are starting with one simple classification problem. This is where we are starting the classifying part. So that is the binary classification. Okay. And since the original label vector, it contains 10 classes, we need to modify the number of classes to 2. So what we can do is we can modify the number of classes to 2. We can, what are the 2 classes? So either 0 or non-zero. So if it is 0, then 0 will be changed to 1, and all other labels will be changed to -1. Okay. That label vector we train as y train 0 and y test 0. Okay. So what is y train 0 and y test 0? These are the label vectors. Okay. Y train 0 equal, now we are initializing the variable names. Y train 0 equals to -1 into the numpy dot ones. What is the y train length? Okay. And y test 0 is the -1 into numpy y test length. Okay. Fine. Then we are finding the indices of digits 0 image. We are remain, okay. Okay. So what we are doing here is we are just modifying. So we are doing a simple classification, binary classification of two classes. So label 0 is changed to 1 only. Okay. So y train 0 index 0 will be 1, and if it is equals to 0, then it is 1, and otherwise it will be -1 only. Now what we are doing is we are doing a sanity check. Okay, so we are displaying the elements of y train and y train 0 to verify whether the labels are properly modified. Okay, so at first it was 10 class labels y train. So there we have 10 class labels, right? So we have 5, we have 0, we have 4, then again 5, we have 6, and we have 8, and so on. But when we are plotting, when we are printing what is the y train 0, what is the label of y train 0, there we did a binary classification, right? So therefore then it will be -1, +1, -1. So +1 is 0. See, my +1 is 0. And what are the other non-zero numbers? Those are taken as -1. Okay. Acha. After that, what we are doing? After that, we are I think we are classifying according to the same. We are classifying this particular previously whatever we showed this data set, this 9 numbers, this 9 labels. Okay, that previously was level 2, level 4, level 0, level 5, level 1, and so on. But here, after the binary classification, that level will be changed, right? Because we have classified as -1 and +1. So again, so level 1, then level -1, level -1, whatever are the non-zero numbers, those are -1, right? And whatever is the whatever are the yes, whatever is 0, that is +1. Fine. Acha, now what else we can do? We can make a baseline model. Yes, so we are making a baseline model with the rule. So we can count the what is the baseline model. So the baseline model is to count the number of samples per class, and then the model always outputs the class which has the highest number of samples. So if it has the highest number of samples, that will be the output, and then we can calculate the accuracy. So if you see the accuracy part, so at first we are doing what is the number of the positive ones, and what are the number of the negative numbers. And if we plot what is the strategy is most frequent, what is the most frequent value, because we are trying to predict the class which has it will output the class which has the highest number of samples, right? So therefore we put the strategy to be most frequent, and then if we calculate the training and testing accuracy, then you will see that the model would have predicted 54077 samples correctly, just by plotting the just by outputting the -1 for all the input. I think here it has done the calculation. 1 minute. Huh? Let me check. Yeah. 1 minute. Yes. So you see what is the positive number? So 5923 was the number of +1s, and 54077. This is, I think, the number of the this is the number of -1s. Okay. And then we are calculating the accuracy. We have the training accuracy to be 0.9, and testing accuracy is also to be 0.9, right? So if we have 60,000 data set, and we have 54077 samples, so if we just calculate the accuracy, that is coming to be 90.12%. Okay, so actually sir has mentioned in his video also that only the accuracy is not always a good measure, because the other samples also could be misclassified. So this is not always, the accuracy in this case may not be a good measure. Okay, then if you go to perceptron, it is useful to remember obviously the important concepts. So we have training data of x and y, So training data is denoted with x comma y, where label y is a discrete number, and the features in this case are pixel values of an image. Okay, so the features in this case are the pixel values. Okay, and then there is loss function, different loss function and optimization models. If you go to the parameters of perceptron class, we can see that whatever is this is the important parameters which we generally put, which are the default parameters. So you basically need not pay attention to all the arguments and their default values. And internally we use the perceptron loss, which is hinge loss. Okay, it uses SGD, as we have seen before that hinge is generally used. And how do we instantiate? We can instantiate in this way, that beam underscore CLF equals to perceptron. So we are just defining the what is the maximum iteration and what is the, we are defining a random state. Okay. So this is actually a quite big task. So we are training and predicting. Here we are calling the fit method to train the model, and it will be nice to plot the iteration versus loss curve. So we will see what is the iteration and loss curve looks like. And but sklearn does not have a direct function to plot it, but we will use the partial fit method as the mother ma'am was telling, and it will be demonstrated at the end of the lecture. Fine. Okay. So we have the training accuracy to be 0.99 and the testing accuracy to be 0.989. Okay. And if you go through the remaining, so we can display the prediction and we can check. We can plot a few images in the single feature window along with the respective predictions. Okay. So now you see it is again the same thing. We have for 0, we have the prediction to be 1. And for other cases, it is for the non-zero cases, it will be prediction to be equals to -1. Okay. And so on and so forth. So we can display the images of positive classes from the test set also. So these are from the test set.
Sir,
yeah.
How does it predict 0?
So what we are doing is we are just putting the CLF dot predict function, right? So that on the test set. Okay, that is how we are predicting. So you can just put dot predict on the X test part, and from there it can predict the remaining. It can predict the from the testing data set.
Even for training, right? When we are training, so how do we know that these are the values for 0?
What this prediction does, prediction will predict the label for a given row vector, right? For a given sample.
Yeah.
So this predict will return you this label of that sample. So based on that label, you can know, no, it is a 0 or -1 or +1. So
binary classification, right?
We have assigned that +1 positive is for class 0 and -1 for the remaining class. So actually, if you print this y hat test 0, it will give you a numpy array with number of test samples, but the labels of the test samples will be displayed. If you try to display this y hat test 0, it will give you the labels of the test X test vector. So how will this X test will be? X test will be a matrix, right? It is not an array. X test is a matrix of your test samples,
right,
with each row corresponding to one sample. Right. And y hat test will be what? It will not be a matrix. It will be a numpy array of the labels corresponding to the sample value.
Right.
Yeah. So from that sample value, that label value, we can know. See, in this plot, it is given, right? If you check in the second for loop for j, in that for loop, it will be printed. See, for example, consider the second for loop for j in range of factor. So here, the third line, the second line, see, the title is given as prediction 0. Format is what? zero labels of index plus j. That is the corresponding index of that label is being written on top of this image. So the prediction is coming from your that labels. See, if you go to that zero labels vector, or what it says, zero labels is your y hat text and the index of 0. So that is what it is picking up. So it is picking up all the samples whose labels are rated as 0 for this image.
Yeah,
is that what you want to ask?
No, basically, if we forget the image problem in traditional regression issues, we have the value of y, right? So
yeah,
y, like we train the features to match that value of y.
Correct.
So in this case, we have the image pixels, right? So what will be, like, those are just features, right? What will be the value?
Features will be, we already have our own test labels, right? We will be having our actual labels at hand. Prediction is what is being predicted on this test data. We already know what is the samples label value, right?
Okay, so that is given by the data set?
Yeah, from the data set itself, see when WD showed you, right? We are splitting the initial data set. So the data set completely has labels. It is every data sample has labels.
I missed that.
Yeah. So while we are splitting the data set, we are splitting them into training and testing. And in testing also we have the labels. But what we do while prediction, we do not pass the label for the test samples. We pass only the test samples. Yeah, so we can match and find whether it is correct or not, because that is how we get this confusion matrix. And later, I think he will show you. So
I understand that. That's fine.
Okay. And
okay.
Yeah.
Thank you.
Yeah, I'll just come one. So one thing we can show. So one thing we can show is from here we can see that there are a significant number of images that are correctly classified. Okay, so we can see what are the number, what is the accuracy here also. So we can see that the accuracy which is coming is to be 0.919, which is almost 0.92. Okay. So now this is less than the accuracy score of the model, but still it's pretty decent. Okay. Now if we consider another digit, and say 5 for positive class and all other classes negative, so will it be the same thing? Will it be the same accuracy? Here we have taken 0, right? We have taken 0 as to be the correct classification, and the other case it was in other case it was all non-zero numbers have to be negative. But if we take as 5, then it may not be the same accuracy, we may not get, right? So you can try and check that as well if possible. Okay. What else is there? We have a confusion matrix. We know that using the accuracy alone to measure the performance may not be always suitable, right? So what are the other measurement metrics that we have? So we have confusion matrix, obviously. Confusion matrix, we have y hat train and y hat test, right? So here you can see we have true labels to -1, it is 53955, and for +1 it is. So if it is this is true, the vertical one is true label and the horizontal one is predicted label. So if -1 classified as -1 is 53955, -1 classified as +1 which is predicted as a +1, that is 122 and so on. Now what we can do is we can calculate the precision and recall from the classification report, right? So we have the precision and recall value to be what we know, right? What is the precision and what is the recall, what is precision, recall, and accuracy? So that is TP by true positive plus false positive. That is precision. Sorry, and we have recall, which is true positive by true positive plus false negative, and accuracy is true negative plus true negative by true negative plus true. All data set, all the 4 quadrants: true, negative, true, positive, false, negative, false, positive. Now, what is the precision and recall values we are getting? So precision value is close to 0.98. Okay, now we can increase the precision, but we will see that later. And what is the recall value is also 0.92, and accuracy is coming as 0.99. Now for cross validation, we can use cross validation folds and measure the same matrix across these folds for different values of hyperparameters. Okay. Now Perceptron does not have many hyperparameters other than the learning rate. We can use grid search CV. We will set the learning rate to its default value, and we can use grid search CV to find the better value for the learning rate, right? So this is the code for that. We can use cross validate, then scoring equals to precision recall, and return estimated to be equals to true. Okay. Then again we are calculating the average and standard deviation of scores for all these three matrices matrix on k equals to 5-fold. To measure the generalization, we have the precision and recall value 0.96, 0.92, around it is coming. So these are the remaining generalization ways. So Amruta, would you like to say anything on this parts? I think we can jump over this parts, no? What do you think?
Just any doubts regarding this confusion matrix, or how do you fix this true positives, true negatives? If they are clear,
Anyone?
then I think we can skip.
Bhupesh or Kanika, is any doubts in these portions?
Is there anything special for image algorithm, or it is general concept? Like general concept, I know confusion matrix, but is there anything special here?
No, I'm just asking, in this confusion matrix we have, right? That is true label, predictor label, and we have the true positives, false positives, true negatives, and then these 4 values. So these are taken from binary classification. So this confusion matrix displays you a binary classification, right? So from this figure, you can easily identify the true positives and for true negatives. So what is the value for true positive here?
5470.
Yeah, correct. And true negative?
53861.
Okay, yes. So these two are pretty simple to clear. No? Okay. So can you tell me what is false negative here?
False negative is 216.
So false negative, how do you know that this is the false negative?
So basically, it's false means it predicted value is not matching with the expected value, and it was -1.
Yeah. So in general, see that is a -1. You're telling based on this predicted and true label. So I'm just asking you, see, for example, here -1 is a negative label, right?
Right.
And +1 is positive label.
Positive, right.
So how do you say it is a false negative? A negative class is falsely classified as a positive class. So that is why it is a false negative, because there are some misconceptions in this confusion matrix.
Exactly. Yeah.
So one thing you just remember clearly is when you get a false negative, it means a negative class is falsely interpreted as a positive class. Similarly, for false positive, a positive class is misclassified as a negative. That is why it is a false positive. So these two concepts, if they are clear, then only you can get the precision and recall values as correct. Because if you misinterpret this false negative and false positive, the values of recall and precision and everything will go wrong.
Yeah, I understand that.
Yeah. So this is for a simple, in binary classification, it's simple to get all these 4 values. When we go to multi-class classification, at that time, the confusion matrix is very big, and then there the confusion arises. How do you pick this? How do you fix more than in 2 classes as which one is positive or which one is negative? It's difficult to fix, right?
Yeah.
So maybe here we can show.
Yeah. That's
I think the diagonal. Okay, so the diagonal classes are the correctly classified classes, right?
Yeah, the diagonal classes are the correctly classified.
And the which ones are in purple? I mean, the dark colors, those are the misclassified classes.
The off
So here,
diagonal
like,
elements, no, we cannot fix them simply for this confusion matrix. If you want to have the equations, no, they are pretty different when you compare them to binary class classification. Because a precision for a binary class classification is simply true positive by true positive plus false positive, right? But for precision for such multi-class classification is difficult and different.
Okay, but can we say, like, suppose here the predicted label for 4 is 333, but true label is 9. So 333 cases of 9 were falsely predicted as 4. Can we say something like that?
We can interpret the results from the matrix, but quantitatively we have to provide this precision for each and every class, right? For precision for 0th class, precision for first class.
Obviously.
Likewise, we have to consider.
Okay. Yeah. Thank you. That's
yeah.
good. Yeah. So yeah, obviously we can make a pipeline also, and the same whatever we have done, we can keep in a pipeline. Let's create a pipeline to keep the code compact, and even this does not require much pre-processing as it is a standard thing. The only thing which we are doing is we may use this to scale the features within the range of 0 to 1. So we are using min max scaler and we are using perceptron. Okay. And so we have fitting data sets. We have steps. What are the steps that we have? Standard scaler, min max scaler, and perceptron, right? And we have the different again a binary classification we have done the same thing, and we have done the iteration versus loss curve with the partial fit method. So in that partial fit method, again, as it is a quite big data set, we have used partial fit, right? So you can see how it is done. It is CLF the bin underscore CLF1 dot partial fit, and then we have put X train, Y train, and what are the classes. Then what we do is we calculate the iteration versus what is the training loss which we face in each iteration. So what we can see here is that the although the number of iteration proceeds, the training loss is always a bit what should we say, always stays in, although it stays within the it varies a lot, but it varies within a particular limit mostly. So it does not I mean increase. I mean, two cases are there where there is a peak. Okay, it has gone up to 0.7, but mostly it stays within 0.4 to 0.6 only. That is the only thing which you can see from the iteration versus training loss curve, right? Amruta, any other thing which we can comment from here?
No, Devi, it's fine.
Yeah, I think so.
We are jumping like the training loss is jumping between peak and bottom, right? So how do we decide which is the minimum? Like it can go on.
Sorry.
So how do we decide which is the minimum training loss? Where do we stop?
So I think the after 100 also it is not stopping. I mean, it is keeping in the same range only.
Yeah.
Right. So 100 will be sufficient, I think, for the time being to keep in the to stop at a particular
the
point.
loss was minimal at 80, right? So in that case,
yeah,
take this.
But
80.
that is just
Yeah, that's why I think we can use this grid search, no, for finding the parameters.
Okay. Yeah.
So this will pick this, and the next session will tell you the answer.
Okay.
Yeah, but we'll show the some of the practice assignments also, because the next session will anyway be on the quiz revision also, no?
Yeah. So in general, if you sorry, just an idea. So in general, if you fix this iterations and all, no, you will not know which is the minimum and all.
Right.
So there is no way we can get what is the minimum value of loss. Should we stop at that iteration or not? So it may get stuck in local minimum, it may not reach to global minimum. So there are issues like that. That's why they decided for this grid searching. That is hyperparameter tuning, right? So
Right.
we can find the iteration. If you're searching for which is the correct iteration, you can do a hyperparameter tuning for that particular iteration parameter, so
Right.
that you will get the iteration which gives you the minimal loss.
Got
So
it.
that is the only way we can fix, because otherwise we have to do some manual plotting and all.
Got it.
Yeah.
Okay. Okay. Yeah, so we have the grid search CV also. So this is the code. You can maybe you can take the screen, take a screenshot also if required. So you can put grid search CV and so, but the thing is, no matter what the learning rate is, the loss never converges to 0, as the classes are not linearly separable. Okay. And so the base learning rate which they obtained is 0.125. And yeah, so for eta 0 equal eta not equals to 1, the training loss was again 0.4 to 0.5 and so on. But if we put eta not equals to 0.125, then only we are getting the training loss to be very low, right? I mean, even less than 0.1 value we are getting the training loss to be. Now instead of instantiating a perceptron class and retraining the model, we can get the best estimator from the grid search CV, and we can actually calculate the classification report and see what is the -1 and +1 precision and recall values and equal scores, and so on mostly. So there are some more things which can be done. Some optional works are there, visualizing weight vectors. I need to check whether sir also has gone through the weight vectors part. Okay. If you need anything here, just let us know. This is mostly on classifying the data set only, on binary. Looks like binary classification. Yeah. To look into the samples which are misclassified as false positives and come up with some possible reasons. So these are okay. Okay. So we will look into this. Maybe in the next session, if you require, just let us know. Okay, we'll look into this session, this portion. Apart from that, what we had is the practice questions. Okay, so practice questions we had again on MNIST dataset. I'll just go through maybe 1 or 2 questions. Remaining questions we'll do in the next session when we are doing the solve with instructor and the so in that session only. Maybe with week 6. Yeah. Hello. Yeah. Tell me.
Yeah. Okay. I was just saying okay.
Yeah. Okay. Okay. Sure. Yeah. So we'll maybe do 1 question and then we'll do the remaining on the later dates. Okay. We have 1 MNIST data set from OpenML. So first question was how many number of samples are there? Again, we have seen that what is the shape and we were discussing that. So obviously we have 70,000 data set and 784. So that is the shape of the matrix. So the number of samples are 70,000 and access the sample at the index 2022. Okay, fine. So from 2022, what is the sample there? So we can calculate what is the label, what is the mean, okay, and what is the mean? What is the maximum value? What is the mean value of the sample? How many zeros are there, and so on. Okay, so that also we can calculate. Sorry. Similarly, there are other questions also like create a data set by taking the first 10,000 images and the next 2,000 images for testing and answering the questions. Okay, so we'll see those questions maybe in the next session. So we'll try to take the next session, the coming session in this week as the revision for quiz. Okay, quiz 1. We'll see if whatever be the case, we'll announce it beforehand. This part, week 5 practice, week 5 graded if possible, if the deadline is over. Week 5 solve with instructor, and this thing, and the week 6 whatever is we can do, we'll do in the next session maybe. Okay. So Yeah, I think we'll stop here and we'll continue from the next session. Amrita, you want to say something?
No, Devi, just okay. If they have any doubts regarding the week 5 contents, they can ask. Otherwise, we can close the session.
Yeah, you can post in the so everyone who may be seeing the recorded session also, you can post in the discourse. There are lots of discussion happening on week 5 content, so you can post your questions there and try whether and check whether your question is already asked by somebody. Okay, so we'll answer the question remaining questions in discourse. Okay, I guess yeah, that's
Yeah,
that. Let's
nice session.
yeah. Okay, thank you everyone. Yeah, Amrita will switch off then. We'll sign off then. Okay. Yeah.
Yeah, okay.
Yeah. Bye. Kanika asked to upload solutions of week 3 and 4. Week 3 and 4 is not solution, is not graded solution. Na? Solution is not uploaded. Kanika, the assignment deadlines are over, right?
Yes, sir. The assignment deadline was on Monday only. Oh, sorry, Sunday only. So that has passed.
Okay. Sure. Sure, week 3, obviously, we'll upload. Yeah, sorry. Thanks for letting us know. Okay. Yeah, we'll upload. Yeah. Thank you. Yeah. Okay, Amrita, bye then.
Yeah, okay. Bye.
Yeah.